Hello everyone. Today I'll be talking about how to apply VLMs to documents. So VLMs stands for Vision Language Models, and I have some experience in applying these models to real-life documents, particularly within the building industry, which is part of what I work on. So I'll be sharing some tips and tricks on how I do this in practice, basically. So my name is Ivan Kjosbakken, and the goal for today is to highlight how to perform advanced document analysis with vision language models. So, just to start off a bit about me, my name is Ivan Kjosbakken. I am currently working as the data science lead at a startup based in Oslo. And with that, I'm responsible for the AI team essentially and in charge of all the AI initiatives that we do at the company. And of course, we're a technology startup, so AI is a very important part of what we do. So it's super exciting to work on, and we're working on a lot of different challenges, but mostly within the document AI space. And I have a master's in computer science, and I've been working on AI and automation for around 5 years. Um, and I have experience as both a consultant within research and in a startup where I'm currently working. So let's just jump straight into it. Why do we need vision LLMs? So vision LLMs is kind of another word. It's a bit of a mix of what you call vision language models. Some people call it vision large language models. Some people call it VLM, so vision language model. And yeah, so it kind of varies a bit, but they're all referring to the same thing. They're referring to a model which takes an image in plus some text and can output text. So let's talk a bit about why we need this. I've provided an example here, which is a very, very real example. I've seen it in countless documents. And this is where you have a series of checkboxes and some text corresponding to each of the checkboxes, right? And as a human, it's super easy. Like, what are we trying to interpret in this part of the image? Obviously, as a human, you can see we're looking at some electrical. We're looking at the fact that electrical is the relevant piece of text. Architectural is an option, but it's not selected. And HVAC is the same. It's an option, but not selected. So as a human, that's super easy to see. But if you apply OCR to these, or like to an image of this, what you'll get out is just the text, right? Because OCR is designed to extract the characters of an image, not symbols, right? Not this circle. That's not what OCR is designed to do. It's designed to extract text, and of course, then it misses the symbol here. And for those of you not aware, OCR is optical character recognition, and it's basically taking an image in and text out. So this is one example. We need a vision LLM because OCR simply doesn't cut it. And yeah, I just want to specify what OCR is. As I mentioned, it's optical character recognition. You can interpret it as read text from images. So I've taken an image here, which I found online, and we can apply OCR to it, where you see, just making sure my image isn't overlapping here. So we have the Arkiplan, you can see the text extracted here, 75 Cardiff Road, CF15, the email address, and so on. So I think this is a pretty simple OCR task, right? It's able to extract all the text. I think something to take note of is how, like the order of the text, right? So OCR is designed to go left to right, top to bottom. So if we read left to right, top to bottom, we see Arkiplan first, right? And then 75 Cardiff Road and so on, right? So we're going to read here, we're going to read the 74 Cardiff Road, then we're going to read site, right? But interestingly, you can see that site belongs to the 82 Edward Road, West Bridgford, right? So you know that the site in this image is 82 Edward Road. However, in the OCR text, that is not the case. Site is extracted here as a word, and in the extracted text, site has no correspondence to the 82 Edward Road, right? So if you now applied an LLM to this text, right, you would have, like if you're using a normal LLM like ChatGPT, you would have to only use it on a piece of text, you would see it will track it, right? Because it wouldn't know that site corresponds to 82 Edward Road. That would be a challenge, something to be aware of. And also LLM, that's a large language model. Most of you probably know what this is. You can input natural language and it outputs natural language. So it's typically used to answer natural language questions, such as what is the date? You can ask that question. You can give in the document text, which we just extracted with OCR, send it to an LLM, and then it can, of course, respond with the correct date. Now, OCR plus LLM is kind of the standard or old approach. I say old, meaning a few years old, but it's kind of the approach that was used when ChatGPT was first launched. So you first OCR the document to extract the text, right? Document image, OCR, then you get the text. You can then ask the question, send both the question and the document text to the LLM, and you'll have the answer. So this is kind of the alternative to vision language, right? To vision language models. You have OCR plus LLM on one side, or you can use vision language models directly, which I show you in this image. And just you can see that it says just response there. So what are vision LLMs? It's like ChatGPT, but you input images instead. So you take the prompt and an image. So you can still ask a question, and then the output is a text. For example, is this a drawing? And then input an image of a document. You can feed it to a vision LLM, and it's going to give you a response in text. So, yeah, I'm coming back to this example again because I think it's really, really interesting why we need vision LLMs, right? That's as I covered earlier, that the word site does not belong to 82 Edward Road anymore. It's lost the context. This is why we need vision LLMs, because vision LLMs wouldn't lose this context. They would use the image directly, and they would know that site belongs to 82 Edward Road, and you wouldn't have this challenge that we now have because we did OCR plus LLM. So what can we do with VLMs? There's basically an unlimited amount of tasks that you can do with VLMs, and they're really, really cool models. But I've highlighted 3 kind of high-level tasks that you can do with them. You can do question answering, right? Just like ChatGPT. You can upload an image, ask a question, is this a drawing? You can get an answer or a response. Another very common task is metadata extraction. So typically you would upload a drawing, you would have it extract some sort of pre-selected fields. So for a drawing, you might want to know the discipline of the drawing. Is it a civil engineer? Is it an architect, etc.? Or you might want to know the date of the drawing. That's interesting, and so on. So just extract a series of fields. And the last task I'm highlighting here is classification. So you can classify, for example, if a document is a drawing or not. So you take an image, you ask the model return true or false whether a drawing is whether the document is a drawing or not. So that's a typical classification task. They can of course be more complicated. So question answering. What is the current and potential efficiency rating? That's a very common question we see. This is again an example document that I found online. And this is a very interesting document actually, because again, you could do OCR and it would go left to right, top to bottom, but it would be somewhat challenging for the OCR to know that, to know which efficiency rating this building has, right? So we have the current one, 49, and the potential one, 76. But if the order of the text is messed up here, you could be in big problems or have big issues, because you wouldn't know, you would then lose the context of, does this 49 number belong to F, E, or D, right? Or the potential number, does it belong to E, D, or C? So in this situation, using a vision language model is also super powerful, because you can just interpret it directly. It's as if a human would have looked at the document. You look at the document and you can immediately see, yeah, it's C. That makes sense, the color matches and is on the same row, right? That's what vision language models does. They just look at the image, they can output text, And of course, humans are pretty good at these tasks, so replicating human behavior is a very good thing in this case. So extracting metadata is another very cool task, and it's also something I've spent a lot of time doing. I've actually fine-tuned a lot of models to extract metadata from documents, particularly with the Qwen series of models. And it's super cool to fine-tune models, of course, and see their performance go up when you spend hours of compute training. However, I've noticed more and more that this fine-tuning is becoming less and less necessary, because we notice that the frontier models, the closed source frontier models, are essentially good enough. So you simply have to spend enough time tuning the prompts, and in most cases the performance is acceptable, and you should not be spending time fine-tuning, because fine-tuning models is super time consuming. And even after fine-tuning the models, you have to of course care about model drift and making sure the model is updated like from the training dataset, that the inference dataset is the same as the training dataset. And you also have to host the model yourself, right? Which brings its own set of challenges. Now you have to have a robust system, you have to have uptime. What happens if a GPU crashes? There's just so much um, extra work associated with hosting your own model and running a fine-tuned model, that I almost always recommend using a closed source closed source frontier model, such as the model from ChatGPT, OpenAI, Google's Gemini, or in many scenarios you could use Anthropic's models, but for they're not exactly known to have the best vision language models, so I probably wouldn't recommend it in this case. But Mistral is another very good model provider. So yeah, so you can extract metadata, right? And in this example, I show you what is a drawing, and it has some quite a bit of information in the drawing box. And some typical information that you would want to extract is the scale of the drawing, right? See, it's 1 to 100. The sheet size could be interesting. Which sheet is it drawn on? The date of the drawing, as a very common thing to wanna, or a piece of information to extract, and then the sheet number. And date is actually a particularly interesting field, because one problem that you might encounter is European and American date formats. Sometimes it's impossible to distinguish, but sometimes you can have dates that doesn't make sense in one of the formats, right? If the month is more than 12, you know, it's the opposite format of American and European, right? But these are all pieces of information that are super interesting to extract. And essentially what you can do here is just you can prompt a model, like extract scale, sheet size, date, sheet number, maybe give some information on each of them, like scale is typically a number like 1 colon and then a second number, and the second number is almost always higher, right? You can give the model this extra piece of information to make it even better at extracting the information. But as I said, if you apply the frontier models to such a document, at least, you'll have great success extracting metadata from it. So what can you do with this metadata, right? One thing is extracting the metadata, but you need to extract the metadata for a reason, right? You need to do something with this extra information that you've now extracted. That's where metadata for downstream tasks come in. So I've just listed up a few examples of downstream tasks that metadata is useful for. You could use it for keyword search with filters. So, for example, if you have a large document corpus and you want to navigate it, you can do keyword search. You'll probably get, let's say you do a generic keyword search like architectural drawing. You can then start filtering, right? Or you can search for find all 1 to 100 scale construction drawings from 2016. Or let's say that's what you want to do, right? You can then do a keyword search for construction. So you find all documents containing the word construction, typically from OCRing. You OCR the text. then you index it, and then you can keyword search. You can then use the date that you extracted, right? You can do a filter on 2016. You can then filter on the scale that we extracted, and then we'll find the correct results to the user. So it's basically super valuable when it comes to finding the right information. If you know you need or can filter on certain pieces of information, such as scale, date, the type of drawing, the sheet size, etc., then extracting metadata is super valuable. Another context where metadata is valuable is for LLM context. So you could imagine that you have a RAG system consisting of all your documents. It's a very common situation to be in. And you could, of course, just index or embed all of the RAG chunks, right? Like super typical RAG. You take the document, you extract the text, you split it into overlapping chunks, you embed the chunks into a vector database, and now you can search for it. You can add more information here, right? So for each chunk of a document, you could add like this document has the date, so and so on. It has the scale, so and so on. And this is super valuable extra context that will be useful in your RAG system, for example. You can also use this metadata for other metadata extraction, which could be an interesting use case, but I'll not dive deeper into this now. So keyword search with metadata. I just want to kind of go a bit more into depth in this. So the advantage here is that all metadata is pre-extracted, or that could be an advantage and a disadvantage. The advantage is that you don't need to calculate during inference time, right? So if a user searches for a piece of metadata or filters on it, it's instant because you already extracted the information. The downside, however, is that you need to know which information to extract beforehand, right? So if you're not doing extraction in real time, you need to decide beforehand, okay, I want to extract these and these fields, like date and sheet size, for example, which could be a disadvantage because you don't always know which fields a user wants to filter on. However, from experience, you can cover over 80% of use cases, or you know over 80% of use cases beforehand, and so pre-extracting metadata is usually completely fine. So you can then filter during inference time, and essentially just makes it easier to find the drawings or even the documents in general that you're looking for. That's why keyword search with metadata is so powerful. So another use case that you can do with VLMs is classification. And is this a drawing is a very typical classification task that's done, where you simply input the document or the image of a document, and you ask the model, is this a drawing? Typically ask it to reply with true or false. And yeah, this could be, of course, valuable for downstream tasks, such as filtering. Maybe you want to filter on drawings or not, and so on. So you would, for example, input this image. You would tell the model, is this a drawing or not? And it would look at the image and then immediately, of course, see that this is not a drawing. And on this document, it should hopefully return true, that it is, in fact, a drawing. And I think you'll probably encounter more edge cases than you think with these classification tasks. And this is kind of basic machine learning knowledge that's not only relevant now with LLMs, but it was always relevant kind of after the release of, or after classification models became a thing, when you had the MNIST dataset and so on, right? So this is kind of goes back to older machine learning, but you will encounter some of the same problems with VLMs for classification as you did with kind of the standard classification models, such as BERT, for example, or ImageNet. So yeah, some of the challenges you'll face is that you'll have some edge cases. Maybe you have a document that is both a drawing and not a drawing. What do you do then, right? I think the good thing about VLMs and LLMs, for that sake, is that they can provide reasoning, right? So you can make them do a prediction, but you can also then make them give you a confidence they have in that prediction and the reasoning. I said that this is a drawing because I'm seeing a lot of lines here. I'm seeing measurements. I'm seeing a drawing box in the bottom right. it all makes sense. And then you can at least understand what the AI is thinking. So I also want to highlight some of the challenges in handling documents here towards the end of this webinar. And a few challenges that I've listed here is there's different languages. So you have to deal with different languages, which could be a challenge. In Europe, for example, there's a lot of different languages, even different characters in different languages, which could be a challenge to deal with. You have handwritten text. So not all documents are perfect. Some of them will have signatures that's handwritten, filled in values that's handwritten. Even the whole document could be a letter that's handwritten. There's a lot of different handwritten text you'll find in different documents. And then some documents are just chaotic, like this one. And there's so much information right here, right? So of course you have the structured information towards the bottom of the document, and that's fine. But if you look in the middle of the document here, this is pretty chaotic. And you have hidden text, so you have text hidden behind lines. And you also have some vertical text like this. The name of the road here is kind of over a 45-degree angle. It's closer to like 60 degrees. And if you applied OCR to this, you would not get good results. I can tell you that right away. If you apply traditional OCR such as Tesseract or similar models, like pre-LLM models, you would have big trouble with this document. And the reason is that the traditional OCR models, of course, depend on kind of looking at the lines in the documents and being able to recognize the lines that make up a character. And when you have a character, so like a letter, but it's mixed with lines in every different direction, that confuses the models and they'll perform very poorly. So you can try this yourself. Just grab a drawing like this and apply Tesseract to it, and you'll see it probably won't work very well. So different languages, that's usually not a big deal. So vision LLMs are language agnostic. Most of the LLMs or vision LLMs out there are best in English, simply because English is the most common language online, at least in the West, and that's why they're best. They have the most training data in English, and the models are going to be best in English. However, there is so much training data of different languages still. Yeah, for example, Norwegian. It's quite a small language. It has like 5 million speakers. And still the model is able to understand Norwegian. And the reason for that is just that there's a lot of Norwegian content out there, right? There are newspaper articles, there are countless books, forums online, right? There's a lot of examples of Norwegian content online. So even though there's super little Norwegian content relative to English, there's still a lot out there, and thus the vision LLMs are language agnostic, and they are able to read Norwegian and other smaller languages. Now, you could definitely encounter problems if you start working with a super small language, such as maybe Sami could be challenging. But in general, if you're a country of more than 5 million speakers, then you'll probably be fine. Definitely for European languages. And then if you start encountering problems with an unusual language that the models do not support, then you can probably find specifically trained models. So people fine-tune models all the time on different languages, and yeah, that is one way to solve that. Handwritten text. From my experience, the frontier vision LLMs are actually better than humans at reading handwritten text, or definitely better than the average human. So I have not encountered a situation with frontier models now where I am able to read the text and the VLM is not. So essentially it's better than the average human, at least. And basically that means handwritten text is not a problem at all. So I would, on a general note, I would say that if the handwritten text is readable, the vision LLM is able to read it. And this is super powerful, of course, because handwritten text has been a challenge with OCR previously, or traditional OCR. The reason for this is, of course, that handwritten text is super inconsistent. Some people write handwriting in one way, other people write it in a completely different way, and that's what makes it so challenging. But the reason it works so well with LLMs and vision language models is that they have so much training data. They've looked at so much more handwritten text than these traditional OCR engines, making them better at reading the handwritten text. So that's not a problem. And also drawings are chaotic. Hidden text, vertical text, and understanding the visual content, which I'll get into. So as I mentioned earlier, if you applied a traditional OCR engine, such as Tesseract, to this image, you would have big problems. And the reason being that you have all of these lines in different directions. So of course you have the letters which you want to extract, but you also have all the different lines here that that confuses the model. And this traditional OCR models are trained to kind of recognize the flow of lines in a document. So it tries to kind of look at the lines in the document and see if it's looking at a character or not. When there's so many different lines here, that will confuse the model. You'll definitely see a lot of examples where the model think there's a character in the image, for example here, but there's not actually a character, obviously, as you can see as a human. Or the opposite is the case. So there's a character, for example, hidden behind the line, which the model is not able to pick up. But the vision language models, again, they have a lot more training data. They've seen a lot more text. They've seen text that's hidden behind lines. They've seen vertical text, or slightly vertical text like you see here. And essentially, they've just seen this in the training data, which makes them able to read hidden text and vertical text. And lastly, I also want to highlight understand the visual content. So, of course, as a human looking at this image, right, you immediately see what's going on here. There's a road going down the middle here. You can read it because it says road here in Norwegian. And there's a lot of buildings on the side here, and there's more roads. So we're probably looking at somewhere in the city center. If you're using an OCR model, it would not be able to understand that. The reason for that is that OCR models are trained to extract text. They're not trained to understand the contents of an image. They're simply trained to extract the text of an image. And this could be a challenge, right? Because sometimes you actually want to know what you're looking at. Someone might want to search for this document and search for streets in the city overview drawing. And if you just did OCR on this document, you wouldn't extract any such text. So it wouldn't hit with a keyword search, for example. But what you could do is you could apply a VLM to this document and make it have a summary or an explanation of the document. Describe this document, and it would describe to you. You can try it yourself. Simply upload an image like this into Gemini or ChatGPT, say describe this image. It will probably tell you something along the lines of, I'm looking at a drawing here. It seems to have some streets in the drawing and some buildings besides the streets. There's a lot of different streets in the image. I'm seeing at least 1, 2, 3 here, and then 4 roads, and so on. So if you then did a keyword search on this drawing description or summary, then you would have a hit, right? So that's one of the benefits of vision language models. So just to sum it up and help us understand, VLMs are required to process visual information. So if you have documents that contain visual information, you need VLMs. OCR plus LLM is not enough. VLMs is the tool to do the job. You can extract metadata with VLMs, metadata extraction such as the date of a drawing or the scale of a drawing and so on. And you can use this for downstream tasks. So you can use it for keyword search and then filter. You can provide it as LLM context, for example, in your RAG application. There are also some challenges in handling drawings. So you typically have different languages and handwritten and vertical text. But VLMs have seen a lot of training data in both different languages and with handwritten and vertical text, which makes them super able to handle these challenges, and which essentially makes them really good models. So that's it. You can find me on LinkedIn, and that's about it.